Hello everyone, this is Misha. I'm doing this project for my multi-core architecture review 3. The topic that we have chosen is face liveliness direction. The implementation purpose reviews MATLAB. The team members are Misha, myself, Pavithra M, and Aarthi Celestis. We are doing this project under the guidance of Dr. M. Rajashekar Babu sir. So let's get started. Initially, we'll be covering about the primary issues or the basic purpose of doing face reduction on MATLAB. First is to reduce spoof attacks. Spoof attacks is also called as spoofing, where a particular person's identity in a system can be spoofed using a photograph or a portrait, a picture of it, where a person authentication gets breached here. And lack of liveliness direction in systems. The systems that are in the present era are not featured with liveliness direction features where a person's identity is checked only based on anything. It can be a picture, it can be a person sitting in front, so it doesn't literally feature out whether he is live or not, or is it a picture. That's the main drawback, and that is why we have created a face detection authentication using MATLAB. Now, varying illumination, expression changes, occlusion, post extremities, and requirements on real-time objectivities. Many categories, many features like illumination, expression changes, occlusion, and post extremities are now not dealt in face recognition. Only a person's face is given for recognition, or an image is given for recognition, where the system just checks into the database and then it recognizes the person's identity and the person gets logged in. And the main objective of this project is to deploy liveliness detection. Not just detecting a person's face, it has to detect the liveliness. It has to check whether the person's face is real or not, or whether it's a photograph, and find a feature in a face. When it comes to liveliness detection, a person's feature or the features in a face plays a very key important role. Each part in a face has different features. For example, our eyes have a different feature, a face, a cheekbone, a jawline. Every single part in a face has a different feature. So all of this will be taken into account while doing the implementation. And the next point is image processing technique. We are using, along with MATLAB, we are using a little of image processing technique, which will be explained in the later slides. And facial expression detection. It not only checks for the authentication, or not only checks for the person's face, it also gives us an outlook of how the person's expression is in that particular mood, whether he is angry or sad or happy, and all of that. Everything is dealt. It's an overall face recognition, and that is implemented using MATLAB. This slide deals with the overall model or the overall architecture of the implementation part. First is the input frame. In the input frame, a person's photograph or a portrait is being sent to the system, where the face alone, and the next part is where the face alone is detected, leaving the body characters and the body parts, and then the face registration. Before performing a function, the face is registered in the system in order to recognize or characterize its feature. Then it goes to the feature extraction. The feature extraction part is where the facial expressions or the facial features has been extracted. Then it goes to the classifier of the model, as its name denotes. It's been classified, and then the final is that it goes to a learning or a modeling phase. It has been in the learning or modeling phase been represented in the form of a graphical method, which is easy for visualization and interpretation. Then it goes to the feature extraction, and again it's stored in the database for further references. The entire model works on this way, and let's see in the further slides how it is being. This model is a continuation of the earlier pictorial model. But the main purpose of this model is to match with the template in database. The picture that we have stored should match with the template that we are processing in the face identification part. First is a camera. The person can use a web camera, or it can be any camera, and then it goes to an image containing face, and then the internal resize with processing is performed, and it goes to two parts. It divides into two sections, whereas the first is face region identification feature extraction, and the second one is face region selection. And then all of these operations are performed, and it's stored as a template in database. This is a key feature here. This template and the new persons entering into the system for authentication has to match, and then all of this is displayed in an application. All of this is created and performed in an application where the entire process is visualized, or you can see it there. Moving on to the result part, the display window is a place where you can visualize what's happening and how authentication is performed. Shows the face using the file extraction. The database, the file that has been extracted in the file in the database are being displayed using this display window. Various face feature reductions are made according to the area specified in functions, and modifications are implemented using threshold value. To perform any detection for that matter, there is a threshold value. The system itself is being given a particular threshold value where any operations performed should match the threshold value, and then it has to perform it accordingly. So the output is basically dependent on the threshold value that is being imported into the system.
Now we will see the result of our project. Here in the MATLAB we have a window called as the display window, which shows the face using the file extracted. Various feature reductions are made according to the area specified in the functions. The specific area will be specified using a threshold value. For example, each and every part of the face will have its own threshold value. Like eyes will have its own threshold value, nose will have its own threshold value, and mouth will have its own threshold value. Based on the threshold value, the specific part of the face will be detected. Then these modifications are implemented, as I told, these are implemented using the threshold value. This gains the accuracy of the detecting the face. So this is how the output will be displayed on the display window of MATLAB. Here, as I said before, a threshold value for each and every part will be already programmed into the program. So, if a user gives us threshold value, it will match with the already given values. So, here in this example, the user has given the threshold value of the mouth. So, the mouth part will be highlighted. If he has given an high threshold of an eye, then it will match, it will see in the program what part matches with. So then it will display the eye. So likewise, this increases the efficiency of detecting the faces very exactly and accurately, which is also used for avoiding the face spoofing. So the threshold value is given very specifically. So if the user uses any photos or any other spoofing techniques, then it can be very easily detected using this threshold value. We have thus come to a conclusion of our presentation. So we have presented a novel real-time method for face detection. So using this technique, it can also be possible to image object data. Like we can load some images into a database. Suppose if some person wanted to know what are the images present in the room, they can use image object detectors, and they can know what is object is. Like the fan light, those images can be detected. So if you want to, if you just show the image of that fan or light, it will detect that it is a light. And it is also possible to count how many fans, how many light are there. That all these things are future work. It can also be extracted from this project. We have additionally proposed novel strategies to avoid advanced spoofing patterns like replayed videos and presented photographs, which took advantages of calculation in the object detection stage. So reference, we have referred so many YouTube videos and many journal papers for this project. It is actually it was an interesting and very enthusiastic project. We have really learned many things from this project, and this is really a very vital area. You can really work many projects on this. So there are many reference papers. We have referred us nearly so much, nearly about 25 to 30 papers, many YouTube videos. For each and every process, we referred so many videos and papers, and we have finally come with a good project. Thank you. Thank you, and thank you, sir.